Okay, area under the curve. Well, actually, area between the curves. The trickiest part to this is making a very rough sketch of the graphs so that you know which one is above and which one is below. You don't have to be super precise. In fact, you know, you just really, I know that this is a parabola, shift it up one. There's a positive in front of that, so I know it's got to go upward. You don't have to sit here plotting points to make this really accurate. Really, once I have this vertex, the whole thing is done. Now I know that's a line. All these graphs are always going to be lines or parabolas, and I know that it's up here at 4, and I know that it goes up because the slope is positive, so it's going to go up. And again, do I have to be super precise? No, I don't. So now I can tell that the line is the one that's above. I also need to know where they hit here and where they hit here. Sometimes they give it to you. Sometimes they give you vertical lines that you can use, but in this case, I have to know where they meet. So I have to set them equal to each other. And then I have to solve for x. Set them equal. Bring everybody to one side, right? Subtract the 2x over. Subtract the 4 over. It is Calc 2. You should know how to do this by now. Right? Factor it. Signs are negative and positive. They got to be 3 and 1. So that means that where they're going to hit is 3. That's 3. And then at negative 1. Oh, that's supposed to be a 3. So this is where you integrate from then. You're going to integrate from negative 1 to 3. The one that was on top is the line. And then you have to subtract the one that was on the bottom, which is the parabola. Now it does get messy. These are a huge pain in the ass to integrate. Well, not to integrate, but to plug in. So negative 1 to 3, 2x plus 4 minus x squared minus 1. Probably the biggest mistake I see in this whole question is right there. You don't distribute, you're subtracting that entire function. So you have to make sure that this negative hits everybody there. And then when I do these myself, and I'm going to end up erasing this and writing it again over here. When I do these, I like to rewrite them so that they're in the proper order. I also like to combine all of the like terms because less terms means less integrating and less plugging in. You don't want to integrate all 4 of these when you can just integrate 3 of them, right? I mean, it's more efficient that way. So I'm going to do the antiderivative over here. Add 1 to the power, divide. I mean, this is the easy part. So I say it's the easy part and I screwed it up. Negative 1/3, x to the third. That one, you add 1, it becomes 2, you divide. So that's 1x squared. And then over there, you get 3x. And it's going to be between negative 1 and 3. Like I said, this part is by far the most annoying and difficult part. But I kind of cheat my way through this when I do it. You'll see. I plug in 3 first. You get a lot of whole numbers, and you got to combine them all. I'm not going to have room, so I'm going to have to do it underneath, which I absolutely hate to do. Plug in negative 1. I mean, this part's pretty horrible. Do not feel bad if you make mistakes at this point. This is by far the easiest place to screw up is plugging all in. All right, so look, that's 27. This I should be able to fit here. Don't forget this negative there. That's 27 over 3, but that divides evenly. This is 9. This is 9. Somehow I feel like I messed this up, but I don't think I did. This is negative 1, right? Negative 1 cubed, but then you got to hit it with that negative. So that becomes negative 1/3. I mean, excuse me, positive 1/3. That's positive 1. That's negative 3. I still feel like I'm actually, well, I guess I'll do it. That's negative 9 plus 9 plus 9. Those are going to cross out. Over here, you get 1 take away 3, which is negative 2. I'm going to leave that third there. I'm not going to combine that yet. Then you have, running out of room, 9, take away a third, third, and minus and a minus is a plus. So that gives me 9 plus 2, which is 11. Take away a third. So remember, that's 33 over 3 minus 1 over 3, which is 32 over 3. Okay, again, area between the two curves. So you have to make that rough sketch This one's a pain in the neck to draw. This is very easy to draw. So I'm going to draw the line first, actually. You go to -3. Now, it's going to go up 2 over 1. I don't want to be super accurate, but here I'm going to be a little bit more careful. Go up 2 over 1, up 2 over 1. Right, so the line, I still drew it bad. I'm still going to just cheat. Make my dot bigger so you can't tell I missed. Now, the parabola might be there. You don't know. What I need is I need that vertex. Like I said in class, you have to figure out where it bottoms out. Once you know that, and you know that it's either this or this, then it's over. So I have to figure out where it bottoms out. So I'm going to plug in, right, negative b over 2a. B is -4, right? There's a, b, c. You don't need c, though. And a is 1. So that's 4 over 2, which is 2. That means I know that the vertex is here. So if it's up there or down there, I don't know. So I'm going to plug it in. Plug 2 to get the y value. But I could already see that's 4 minus 8 plus 2. So 6 take away 8 is -2. So that means that the vertex is right here. So that means that it's underneath. So it goes like this, and it goes like this, which means the line is above it. That's all I needed to know. That is the only reason that I had to do that. It seems like a waste of time, but these problems take a lot of time to set up because you have to have that picture. You have to know which one is above and which one is below, or else you can't even set up the integral. What I also need, though, I need to know here. I need to know where they meet, or I don't know what to integrate between. So I'm going to set them equal to each other. I'm going to subtract. I'll write it, even though Calc 2, ridiculous that I would even have to write this, but I'll write it. Right, you set it equal to 0 to factor it. There are always going to be parabolas and lines. They're pretty simple to solve, and they're going to work out. They have to work out for you. They can't give you crazy numbers that you have to use a quadratic formula. So 5 and 1, right? Two numbers whose product is 5. They have to both be negative. So that means that these graphs hit at 1 and 5. Remember, I fudged it. So I'm going to, this takes a lot of writing, so I have to erase this also. Or I'll never fit the whole thing over here. So I'm going to integrate between 1 and 5, because those are the numbers I got. The one on top is the line. And then I have to subtract the one that was on the bottom of it. Now again, this is the number one mistake. You have to take this minus and distribute it to all of these. This is very important. And if you do that part wrong, then you're going to integrate the wrong thing. And then you have no hope. Negative x squared. Negative and negative, right? One at a time. Positive 4x. And then over here, you're going to get the -2. Now, if you're a complete fool, you'll integrate each of these one at a time and then have 5 things to plug into, which is ludicrous and stupid. That's very inefficient. Combine everything together. I like to write them in order. Write the negative x squared. You have 2x and 4x, that's a 6x. And then you have a -3 and a -2, which is -5. And then I'm integrating from 1 to 5. You want to combine them before you start doing the antiderivative. Trust me on this. So integrate, add power, flip it, throw it in the front. Add 1, which makes it 2. 6 divided by 2 is 3. And then just tack on the x here. And this it's probably the worst part of the whole problem because it gets pretty nasty. These numbers are a little big because you have to do 5 cubed, but it's not the end of the world. So listen, what can you do? You gotta plug the numbers in there. This is part of the question. You have to complete it. You can't. I'd love to let you stop there, but if it's asking you for the area between the curves and you're just like, yeah, if you were to plug these numbers in, you get it. But you have to plug those numbers in and get it, and you have to do it without a calculator. But hopefully you're getting used to this in class. 5 cubed, 5 times 5, 25. Another 5 is 125. You'll see that I'm not going to combine things till the very end. That's 25 times 3, so that's 75. And that's minus 25. Try to be very careful, make sure I don't screw this up. 1 cubed is 1, so you're going to have -1/3 there. 1 squared is 1 times 3, and then take away 5. There's a lot to combine here. You can do the 75 and the 25 and make positive 50. You can do the 3 take away 5 and make -2. I will absolutely do that. I'm going to combine all the numbers and then I'm going to do these. So remember, you got to switch here. I have -125 over 3, right? Plus 1/3. Then I have a positive 50. And remember, that's -2. So then it's going to become plus 2. So I'm out of room here, so I'll do it over here. So I have 52. -1. See, this is why I do this. They have the same bottom. I don't have to do that in that step. So just subtract the tops, right? You have -125 plus 1 is -124. So it's -124 over 3. Unfortunately for me, that's not divisible. So there's nothing I can do. Well, stop just in time. I was running out of room. So I have to times this one by 3. So let's see. 156. Right? 150 times 3 is 150, and 2 times 3 is 6. So pretty sure I did this right. So to make the common denominator, right? For those uninitiated, you have to times this by 3 over 3. So then when you subtract them, you get what? 32 over 3. Which again is a completely different answer than I have on my sheet. Which means I must have screwed it up somehow. There, I copied it wrong. No, I copied it right. I don't know what the hell's wrong. Either I did them wrong on the sheet originally, or I did them wrong now. So you guys can watch and tell me if I screwed it up. All right, another area between problem. Now, this one involves all the lines, so it's a little more straightforward. Also, if you use some intelligence, you understand that 2 lines are not going to meet more than once. So, parabola and line, 2 parabolas, they can smack into each other 2 times, and then have your constraints. So y equals x is about the easiest line to draw. It's centered at the origin. Its slope is 1, up 1, over 1. This line starts at 2, and it goes down because it's got a negative slope. Whee! So look, you can see where they meet. Now, but look at what the area would be, right? The lines never meet again. They meet only in this one spot. So you got a problem there. You need something else. That's why they give you this. This is a vertical line. That's basically the y-axis, right? It's a vertical line through 0. Right? That's the y-axis. So that's x equals 0. This one was y equal x. This was y equals 2 minus x. You have to be able to draw these things. So once you have this there, look, you have like this little triangle there. That's the area that you're looking for, right in there. So I need that dot. So I have to set these equal to each other. Now, again, it does not get any easier than this. This is a linear equation. Put the x on one side. I do not want to see anyone else telling me this is x squared. This is 2x, right? One x and another x is 2 x's. Equals 2. Divide by 2. You get x equal 1. So that's the other place where they meet. So they're going to meet at 0 because of this vertical line, and they're going to meet at 1, which is where the graphs touch. It's the only spot those lines touch. Lines cannot meet twice. They don't double back on each other. So the line on top then was this one, right? That's the one above. This is the one below. So this one goes on the top. It's area of the top. Take away the area of the bottom. And again, this is probably the easiest one that I've ever given here. So you're going to have 2. Take away 2x. This is easy to integrate. I mean, I would actually write this differently if it was me doing it, and it is me doing it, so I am going to do that. I would write it this way. So I have the squared thing first. So this is net, right? You add 1 to the power, divide. So it's negative x squared. This one just becomes 2x. And then you evaluate it at 0, 1. It doesn't get any friggin' easier than this because you're plugging in 1 and you're plugging in 0. So first plug in the 1. Be careful, it's still not trivial. Minus, plugging in 0. Everything has an x in it, so when you plug in 0, I just handed you a big gift. So here you're going to get -1 plus 2. Jesus, 2 minus 1. This is like the only answer that I'm certain I did right. Is because it comes out so easy. It's not, it's pretty straightforward if it's all lines, right? They only meet once. I have to give you an additional constraint. I had to give you something extra to cut them off. So that's exactly what I did. So again, set them equal, figure out where they meet. I gave you the other spot where they meet by giving you that vertical line. Area top, area bottom, find the antiderivative, plug in. This is about as easy as it will ever get. I gave you such nice numbers to plug in that it's, I mean, it's absolutely trivial compared to the previous two, which were a lot harder than this.